Alright, so in this video I'm going to explain how you're going to start programming after you've already downloaded that empty project and you've set up your Visual Studio and you know how to open it. So we're going to open the Windows 32 that came with that empty project folder after we've unzipped it. Alright, and here I've gone ahead and written some stuff, but I'm just going to explain this a little bit at a time. So I just deleted it. First thing is, I just want to explain, why did we need this folder in the first place? Why even give us this empty project folder? Well, the reason for that is, if you look up here in these files, remember we created that main.asm a moment ago. So let's look at resource files or header files. Well, header files, we see there's this io.h here, and this is something that Richard Detmer wrote, and it's just basically it's like the higher level files for the program that we're going to be doing. It's got all these instructions in here that tell the assembler to do certain things when we write certain code. So there's all these different kinds of files here that are going to be running in the background when we do our thing, and we're going to get into a little bit about how these are working like later on in the course. Alright, so the most important of those was just the io.h, and that's the one that we're going to end up knowing a lot about by the end. Alright, but let's just look at the files that we're going to be familiar with first. So we see the main file, that's the one that we're going to type our code in, and then there's io.asm, and that's a little bit more stuff written by the author. And what this is like procedures that run when we type certain code. So I'm being intentionally vague because we haven't talked about like what these instructions here, like W2A or A to W, D to A, or A to D are yet. But these are procedures that run when we type W2A. So that's going to be like one of the commands that we can give, and it does all these little subcommands and then sends back the product to our code that we're writing. So that's just a little bit of background, like why we had to download that file. It's going to be completely necessary that we have it so that we can get some kind of response when we type in what we're going to type. So then I'll explain a little bit now about just the general things that you need to have when you're writing the code. So a file name is important. So usually you're going to be writing a lab, and you're going to name that your last name. So my last name, Overby, and just Overby, I usually put like an underscore or something, but Overby lab, and the first one would be 0, and dot, and this is a ASM file, so I'll put something like that. And then the course name, just put assembly language, and then the author, well, that's me, and then the due date, well, I'll just write something, so say like 12/15/2015, or 15, and the program description. So this is where we talk about like what is it that the program does. So let's just say that we're writing a program. This program counts to 10 and displays the results. And a lot of times, like, I'll write the program and then I'll come back and do like the input and output, because at that point that's when I know like what exactly those will be. Alright, so these sections here, these are all very important too. So the .586 section, I think that's just some kind of command for the assembler. And then the model flat, that's talking about like a flat model memory. So you're going to talk about that in your class some. The include io.h is saying make sure that we have this file here, the io.h, and then the stack 4096. It's saying set up 4096, and I think it's bytes, but it might not be. I'm almost positive it's not bits, but yeah, it's probably bytes. So and then the .data, that's like a section where in this section we include the names of variables we will use, and also like some comments on what the variables do. And even well, you're gonna see in a moment, but we can have a variable, something like well, we maybe call it like a prompt or something like that, like a prompt. So that's the variable name, and then a little bit further to the side over here, we'll put something like what the variable does. So I'll get into that in a moment, but the .code section is where the code goes. So this main proc is also included. So down here it'll say main proc and then proc. So make sure you have that, and this has to be like a capitalized, like case sensitive is a must. Like all this stuff is case sensitive, so just make sure that you don't put like lowercase all this, or your program's not gonna work. Alright, so like we're not gonna write a program in this. I'm just explaining a little bit about the structure and like what you need to have, and getting you like a little more familiar. But in the end, whenever you're gonna go write your code, you're gonna want to debug it, right? So you can go up here and you can just click this green arrow, and that'll run your code. But what you're gonna see is in your file that your code is stored, first off, when you open this file in the first place, it creates that .sdf, and when you go and you run this debugger, it creates another folder, the debugger folder. So you can either click this button or you can click F5, and that's gonna ask you, do you want to build it? And you say yes. Alright, and so you can see down here in this output section, it's doing some stuff. If it doesn't end up working, it'll tell you there, like it didn't work. But even though it says right here like cannot find stuff, it did actually go ahead and debug it. Alright, and so we're gonna see down here that it just created this debug folder. So delete this folder before, and delete this .sdf before you turn in your code, or you'll get points taken off. Alright, and another thing I want to show you guys is this debug section up here, this tab, and then Windows. Alright, so before I do that, let me just set what's called a breakpoint here. So you just go to this like gray bar here, and you click it, and it puts a dot. Alright, and then we're gonna try to run the code again. So I hit F5, and it stops at that dot when you do that. So I actually hit it twice, but here. Alright, and then we go up to debug, and alright, well, if I would stop hitting it twice, I think we could get somewhere with this. I'm not sure what it's doing now. Alright, so we go to debug and then Windows, and if we go down here, we can look at this registers. We're gonna open that up, and this shows us our registers. So remember that registers are the things that are inside of the processor that we can think about. The processor does actions on these registers, so it can take one register and it can add it to the other. Alright, so by now, like, you guys should be probably pretty familiar with that. And we can look at the debug, Windows, and memory. So we go down there, memory, and just hit memory 1. And this is what is actually actively inside of our RAM right now. So my RAM on my computer has all this stuff in it, and say that I had named in the data section I had named that prompt after all, then that would show up here. So let me try to do that real quick. I didn't need to close those, but I'm gonna just go back one more time and show you guys like how to open them and stuff. So I'll say like prompt, this is Henry, just something random, right? Alright, so I believe this will work. Might have needed a semicolon, I don't remember exactly right now, but alright, so we're gonna see what happens. Alright, so let's see, exited, yeah, that's right. Okay. Yes. Alright. Yeah, something's wrong. Alright. Usually my intuition would be right about something like this. Alright, well that just showed you an example of what's gonna happen if your code is not right. So we're just gonna skip this for right now, and I'll just explain one last thing. Whenever you go to debug something, you can hit F5 and that'll try to run the whole program all the way up into your breakpoint, and it'll stop at that breakpoint. After that breakpoint, you can hit F10 and it'll go step by step. And you can see the yellow arrow there. It's taking like each and every step through your code. So that's going to be important when you're debugging something. You're going to want to be able to step through your code just one line at a time and see what the results of execution are on the registers and on the memory. So we'll come back and actually start programming next time.